Good morning to all. Today my session is operating systems. Already we covered three topics. Today my topic is real-time operating systems. So we have discussed different types of operating systems we come across. So today we'll look into real-time operating systems. It means real-time system means that system is subject to real-time. That is, response should be guaranteed within specified time constraint. Our system should meet the specified deadline. For example, flight control systems, real-time monitoring systems, like this. So in this real-time operating systems, we got two types. The types of real-time systems should be based on the time constraints. So hard real-time systems and soft real-time systems. So you see, so first of all, real-time operating system means if that instruction is not executed within time, without delay, so we are safe. Suppose if you look at these flight control systems, so if any delay in the execution of instructions or program in the flight will get collapse, or there will be a fatal accident in the air, it's in the mid-air. So that this type of software should be executed within stipulated time without delay. Like our PC, if our OS is not executing within time, or take some delay, then that is accepted. Whereas the real-time operations will not be accepted. That is, that instruction or that OS should be executed within the time. That is importance of the real-time operating system. These types of OS serve real-time systems. Like most of the embedded systems use embedded systems. That one we embed OS in the IC itself. So that will be executing the instructions within a stipulated time without delay. Even small delay is also not accepted. The time interval required to process and respond to input is very small. This time interval is called response time. So that's what real-time systems, real-time operating systems. If the operating system is not responding within a time, then there will be a fatal accident, very damage to the system, the organizations of the components. So the real-time systems are used when there are time requirements that are very strict, like missile systems, air traffic control systems, robots, etc. So two types of real-time operating systems: hard real-time systems and soft real-time systems. These OS are meant for hard real-time systems. These OS are meant for applications where time constraints are very strict and even shortest possible delay is not accepted. These systems are built for saving life, like automatic parachutes or airbags, which are required to be readily available in case of any accident. Virtual memory is rarely found in these systems. So suppose the airbags in the car, when the accident took place, if the airbags are not opened in time, then there will be accident for the driver and the owner of this car who are sitting in the car. So they should not be delay. So that's what the emphasize is real-time operating system. So it means the system already compiled everything. It is just ready to execute. That's all. The execution time is very small. No delay is accepted in that one. So that's called real-time operating systems. So soft real-time systems. These OS are used for applications where time constraint is very less restricted, like our systems we use. So if you look at this diagram, in this diagram, this is application oriented, real-time kernel, and your custom hardware. So things will take within no time, within no delay, things will be happening. So whereas soft real-time systems, there may be some acceptable delay may be permitted. So whereas the real-time hard real-time systems, there is no time delay accepted. So advantage of device, maximum consumption. So maximum utilization of device are systems that more output from all resources. Task shifting. The time assigned for a shifting task in these systems are very less. For example, in older systems, it takes about 10 milliseconds in shifting one task to another. And in the latest systems, it takes only 3 milliseconds. So there is very less time, response time as well as the shifting time is very less from one operation to other operations. Focus on applications. Focus on our running applications and less importance to applications which are in the queue. So what is present, if this operation is not done in time, there will be fatal accident. So that present application is very much important. So real-time operating system in the embedded systems. Actually, most of the time we use this real-time operating system in the embedded systems. So just in the air traffic control systems and the flight system, the parachute will be with the pilot or passengers. If the parachute is not opening in time after jumping from the aircraft, then he will have fatal accident. At the same time, we have discussed that in the car, the airbags are not opened in time, there will be a fatal accident in the car. So that is the OS will be embedded in the VLSI chip, that is embedded system microcontroller. So it is embedded in the embedded systems, embedded cars and aircraft. Since the size of programs are small, RTOS can also be used in embedded systems like in transport and others. Error free. This type of systems are error free. So always there should not be any virus or any errors in these operating systems. So memory allocation. Memory allocation is best managed in these types of systems. So limited tasks. Very few tasks run the same time at and their concentration is very less on few applications to avoid errors. Use heavy system resources. Sometimes the system resources are not so good and they are expensive as well. Complex algorithms. Algorithms are very complex and difficult for the design to write on. Device drivers and interrupt signals. So for these real-time systems, the device drivers and interrupt signals are very much important. So as we discussed in the previous slide, so there will be interrupt signal like suppose one transport is going, suddenly there was accident, suddenly there is impact, accident. So immediately this is nothing but interrupt signal. This interrupt signal goes to program, and automatically the program will invoke the system that airbags to open. So that is called interrupt signals and device drivers. So once these airbags are there in the car, these are connected to the microcontroller through the device drivers. This is your airbags. So they are connected to the through the microcontroller through the device drivers, and that's what device driver also we have discussed. This also is a software which is helping the device to recognize by the controller. So high priority, this thread priority. So out of all these things, if the priority comes, if the signal priority interrupt signal comes to microcontroller, so the topmost priority will be given to the that signal, which is going to airbags to open. So that is highest. That priority is there. It is not good. So to set thread priority for these systems are very less prone to switching tasks. So special purpose systems. There are various classes of computer systems based upon their computational speed, usage, and hardware. The following are some special purpose systems. So we discussed real-time embedded systems, multimedia systems, handheld and portable systems. So operating system devices, services. What operating system will do? An operating system provides service to programs and to the users of those programs. It provides an environment for the execution of programs. The services provided by the one operating system is different from other system operating systems. As we discussed in the previously, This is if you look at this is OS. Inside the OS, there will be number of programs. There are lot many programs. All these programs are there. So maybe lakhs. These are all .exe files. These are all .exe files. Some programs will work for some operation. Some programs will work for some operation. It's service to the user. So if you look at this one, this is your process management, memory management. This is memory management. This is process management. Like some programs are there. This part of security, that is security, and some programs are there. These programs work for your file management. This is security. Like this, there are lot many programs in the OS, all .exe files. So these programs will give some service to the user. That is your process management. You see, the operating system makes the program task easier. The operating system program task easier. Okay, that is its service provided by the operating system is listed below. Look at this one. We will see number one is program execution. What is this program execution? We'll discuss in detail. And IO operations and file system manipulation and communications, error detection. All these things will be handled by the OS only. OS means the programs which are available in this OS. These programs will handle all these operations for the user. So we'll see one by one in detail. So this is a diagrammatically you can see operating system services. So user and other system programs, GUI, this is user interface and command line and system calls and program execution. These are operations what we're discussing. Program execution, operations and file systems and communication, resource management and accounting, error detection and process and security, protection and security. So these are the services provided by the OS to the user. So these are the we'll just discuss one by one clearly. So what is program execution? The program execution is once we install OS in the system, by default the OS will be available in the C drive. So once whatever program we write, either Python or Java, these are instructions. Like these are instructions of suppose you're writing a program for reverse string and all. So we'll write some programs lines. Each line is instruction. Each line is instruction. Instruction 1, 2, 3, 4. So this is a program. We're writing a program in the RAM. Once after compilation of this program, we will click the button for the run. So it means who is running behind this scene. So your OS is only executing this program. What the OS will do, it will get each instruction to the microprocessor. This is your microprocessor or CPU, and it will be fetching, decoding, executing. So that ultimately each instruction will be brought to the microprocessor. At this microprocessor end only, the program will be executed. This is called program under execution. Program under execution called process. So this is called program execution. So who will do? The OS will do. OS only will get this job done. So that is called program execution. System loads a program into memory and executes the program. The program must be able to end its execution either normally or abnormally. So that's what program execution. So who is helping to execute this program? The OS only will doing this program, this work for the user. So user writes simply a program, then he will go for execution. So once you switch on the run, so your OS will only execute this program. It's getting the program line by line to the microprocessor and it will be executed in the microprocessor. That's what program execution. Then IO operations. A running program may require IO, which means suppose one instruction has been brought to your microprocessor. So it is addition. It requires some inputs. So which may involve a file or an IO device. For specific devices, special functions may be desired for efficiency and protection. User only cannot control IO devices directly. Therefore, the operating system must provide a means to do IO operations. So IO operations only user only press the buttons, but rest of the things will done by your OS only. So that's what the file system manipulation. There must be some program behind the OS who is manipulating all these jobs, who is doing all these jobs. So file system manipulation. The program needs to read a file or write a file. The operating system gives permission to the program for operation on file. So many operating systems provide a variety of the systems, sometimes to allow personal choice and sometimes to provide specific features or performance characteristics. So we'll discuss one by one in detail in the coming slides. So communication also. Data transfer between two processes is required for some time. The both processes are on the same computer, on one computer or in different computer, but connected through a computer network. So communication may be implemented by a shared memory, in which two or more processes read and write a shared section of memory or message passing, in which packets of information is predefined formats are moved between processes by the operating system. In this one, communication the concern. Suppose this is a program you are writing, you wrote, and this is your microprocessor who is executing the programs or instructions. So suppose one instruction has entered into the microprocessor for execution. So other instructions will be in queue. So there will be communication between one instruction to another instruction. Suppose one instruction has gone to its execution, so other instruction will be in the queue. So this one is entered in this microprocessor will intimate to the other instructions, the other processes. So by by message passing concept, so other instructions will be in queue. They will be waiting. This is called message communication between the processes. So what is a process? Process means program and execution. What is program? Program, whatever you write with Java or Python or any language, some any instructions in the program. So that should be executed by the microprocessor. So there will be communication between the one process and the process. That's what. So error detection. So operating system needs to be detecting and correcting errors constantly. Error may occur in CPU, in IO devices, or in memory, hardware. The operating system constantly needs to be aware of possible errors. It should take the appropriate action to ensure correct and consistent computing. Sometimes if there is an error, automatically there will be self-healing programs are there in the OS. So they may rectify it and error detection correction also there. So the OS provides the user interface UI, the user, an environment for the user to interact with the machine. The UI is either graphical or text based. So as we're discussing the basic definition of the operating system, operating system is interface between the user and our machine. So while interfacing with the machine, it may be a GUI or text based. Sometimes you type the command and execute, so make directory and all in the Unix, and uh, graphical user interface. We will get the windows on the screen. That is graphical user interface. So we'll see the OS on most computers and the smartphones provides environment with the titles, icons, and our menus. This type of interface is called graphical user interface because of user interfaces interacts with the images through a mouse, keyboard, or touch screen. So this is what graphical user interface. So the command line interface, CLI. CLI means command line interface. So an OS provides a method uh, or interaction that is non-graphical called the command line interface. This is a text-only service with the feedback from the OS appearing in text. So if you look at this, so using the Windows or Linux, you will get the icons on the screen. So this is called graphical user interface. So this is happening in the Windows and Linux. Whereas if you go to DOS and uh, Unix, this is Unix, the DOS and Unix, you don't find any GUI. Simply you will get the command line. command line prompts are dollars like this. Then you have to uh, change directory cd or make directory mdr mk make directory. So this is we have to type the characters and commands that you can enter. So this is two types of interfaces. One is a command line interface and another one is graphical user interface. So most of the times we use graphical user interface only. So we use very less in the Unix and DOS. So whereas in shell and all, we have to use command line interface only. We'll see in the further slides what is the shell commands and that in the CLI we have to type the command and execute it. So these are all services on the still accounting. We want to keep track of which users, how much time and what kind of computer sources. So as we discussing, computer monitors tracks everything what is happening in the system minute to minute. So that is called, they will come, OS will maintain account when the file is opened and when the file is closed, how many times opened by the user. Every account will be maintained in the OS, by the OS. So that is accounting. So protection security. When several separate processes execute concurrently, it should not be possible for one process to interfere with the other with the operating system itself. So that's what I'm insisting. This is our microprocessor. This is our microprocessor, and these are the programs. This is a program what you wrote, and we are going to execute. When we are executing, the first instruction you brought into the microprocessor, and second instruction into the queue. So there should be such a system. No two instructions is trying to enter into the microprocessor for execution. So if we have two instructions trying to enter into microprocessor for execution, there will be hang up. System will be hang up. So we should provide such a programs in the OS. This OS progress will control the complete operation of the complete process management by sending one process or one instruction at a time to the microprocessor for the execution. That's called what is called protection. That is protection and security. So protection involves ensuring all access to system resources is controlled. So system itself is basically we call microprocessor. We have to provide the protection. No two instructions should be permitted to enter the microprocessor for execution. Security of the system from outside is also important. Security starts with the requiring each user to authenticate himself before herself to the system. So usually by means of password. Normally we will provide the login and password system for opening any file. So anybody cannot open the file. So that also we provide by the OS. It is provided by OS only. OS will authenticate the person, then the person will be allowed for the opening the file or your system. So that's what protection security. So next we are going to system calls. So system calls is a this is a OS. This is basically OS. Inside this there are number of programs. System call is a program in the OS. So, but this system call having some other purpose. These are also program. This is also .exe file. This is also .exe files. All are .exe files. They will do some operations. They will do some operations. But system calls will do some specific operations. System call is a way for user program to interface with the operating system. That's what the program interprets several services and the OS responds by invoking a series of system calls to satisfy the request. A system call can be written in assembly language or a high-level language or a C or a Pascal. So system calls are predefined functions that are operating that the operating system directly invoke the high-level language is used if a high-level language is used. So we'll discuss this what system call. System call is a part of is a specific function. They got specific operations, but it is a part of OS only. But one system call will invoke other system call. Ultimately, your program will be executed. So I'll give an example of the system call. Suppose you wrote some program in Java or Python. You wrote some program. Wrote this program. Now, so after writing the program by the user, so you will go for saving. Saving. So if this saving going good save in the D drive or C drive. So this means this part is done by your user only, user part. So after writing the program, he will tell the system to save it. So for saving, he will give some name and some path also he will set. So rest of the job will be done by the OS. In the OS, who is doing save? When the moment you press the save button, it will invoke system calls write. Write is system call. Write is system call. It is in the OS only. Okay. So what it does, it will write this program in the hard disk. So that's what system calls. System call will write this program in the hard disk, then it will return icon on the screen. The once the program is saved in the hard disk. So the sequence you can understand. So first user will write the program, and once you press the save button, automatically this program will be saved in the hard disk. But how it is saving? By invoking the write system call. The save will go. Will invoke the write system call. Right, this is functional, basically a function. Once it is added to the OS, it will become a system call. The write system call will invoke and it will write the program line by line in the hard disk. Then job is done. You will get file saved. So you must have understood what is system call. Basically, system call is a function. Okay. We will add this function call to the OS. Then it will become system call. Then this function belongs to the system only. Now you cannot invoke the write because it is inside the OS. You cannot invoke the functions or programs in the OS. So system itself will call these functions. System itself will call these functions, and it will make use of these functions and get ultimately the job done. This is what system calls will do. So we will discuss the system calls in the next class in detail.
Like, share and subscribe. Hit the bell icon for more updates.